Hi, this is Adolph Oliver, and in this video we're going to talk about ratios and rates. All of this is going to lead us up to slopes and grafting, so that's where we're headed. Anyway, a ratio is a way to compare two things. For instance, your neighborhood might have 6 dogs and 4 cats. Then this can be written as a ratio. What we do is we take the first thing mentioned and put it upstairs, 6 dogs. Okay, and then the second thing mentioned, put it downstairs, 4 cats. Now, this is basically a fraction, and of course one of the standing rules we have for fractions is always reduce them when you can. So even written as a ratio like this, what we tend to do is reduce 2 into 6, which goes 3 times, 2 into 4, which goes twice, and write this then as 3 dogs for 2 cats. Okay, well now, that's what a ratio is, and ratios should be reduced if you can, like we just did. A rate takes that ratio one step further. What it does is it writes the bottom as a 1, so you can use the word per. Per refers to per one of the things. So here's what we can do. We've got our 3 dogs, okay, and 2 cats. So let's set them up here. 3 dogs and 2 cats. Okay. But now what I'm going to do is divide both top and bottom by the bottom. I want to make this bottom 1. So I'm going to divide both the bottom by 2 and the top by 2. Well, 3 divided by 2, I could write it as a decimal, for instance, 1.5 dogs. And down here then we have 2 over 2, 1 cat. Well, the reason we have rates like this, folks usually when they talk about rates are talking about officially what is a unit rate, okay? And you'd have 1.5 dogs, this is how you could say it, 1.5 dogs per cat. The per, of course, means that we just got one of these. So here's the difference. When you're talking about ratios, okay, the bottom doesn't have to be normalized to 1. Whatever you reduce it to, that's fine. But if you want to make a rate out of it, then we're usually talking about one of these unit rates. Then what you have to do is divide top and bottom by what the bottom is, so you get 1 downstairs and the upstairs matches it. So 1.5 dogs per cat would be the same as this ratio here, but now we've written it as a rate. Now, rates can also be used to indicate the rate of change when we talk about graphs. And so let's take a look at some examples to see how that can be taken further. Okay, here's another little practice of writing a ratio and then a rate. And this is very similar to the last one we had. Here's the idea. Whatever's mentioned first goes upstairs. So 6 shirts, okay, 2, and down here goes downstairs, 4 coats, okay. Well, once again, since this can be reduced, it's a fraction, 6 over 4, reduce it. 2 goes into 6 3 times, 2 goes into 4 twice. So as a ratio, we could say this is 3 shirts, okay, to 2 coats. Now, if it would have been that we couldn't reduce this first guy up here, then we just would have left it like that. But down here, 3 shirts to 2 coats, there we are. Now, once again, this is a ratio, okay? we want a rate, we've got to take it another step further here. So here's what it would be as a rate. And remember, when we talk about rates, it's unit rates. We divide both the top and bottom by what the bottom is. Okay, well, here we go. 3 divided by 2 is 3/2, which again we can write as a decimal. 1.5 shirts. Okay. And 2 divided by 2 gives me 1 coat. The key is we want to get this 1 downstairs so we can use the word per when we talk about this. So how we could finish up discussing this as a rate, we could say it's 1.5, or you could say 1.5 if you want, shirts, okay, per coat. And that means for every coat you have, you've got 1.5 shirts. So rate, then we use the word per, but we've got to get the 1 downstairs to be able to do that. Now, another thing that pops up here is increases and decreases. Let's look at this problem. A dozen large eggs cost $2.40 in May and $2.32 in July. Well, that's definitely a decrease. Okay, the price went from $2.40 to $2.32. Well, here's how we set something like that up. First thing we do is we calculate what is the decrease. The decrease, okay, is, well, let's see, we went from $2.40, okay, down to $2.32, so the difference between those looks like it turns out to be 0.08 or 8 cents, but we're still writing it here in dollars notation because that's the way we were given the problem. Okay, now how many months? Well, when you go from May, the next you go to June, and then you go to July. Okay, so we went 2 months. Okay, so here's how we do it. We set this up as the change per month. We want to talk about it in months. Now, writing it as a ratio to begin with, to be able to get it to this rate, what was the decrease? Well, we had a decrease, okay, of $0.08 over a total of 2 months. So I put the months down here. Okay, well, once again, to get it to a rate, this is a ratio here, but if we want it to a rate, we've got to take it the next step. So here goes the next step. Okay, what we're going to do now is divide both top and bottom by what this guy is. We want to change this to 1, so that's why we divide what the bottom is. Well, of course, if we take 2 and divide it by 2, we get 1 month. That, of course, is what we wanted, so we could use the per. We still have a decrease up here, okay, but a decrease of, well, we have to divide 8 by 2, and so that'll give a decrease of $0.04, okay. So we would say then that it's a decrease then of 4 cents, although we'll write it still in dollars notation, a decrease, okay, of dollars 0.04 per month. And remember again, we wanted to use that word per to indicate our rate, and to do that we had to make sure the bottom of the fraction was 1, and how we did that was we divided both top and bottom by whatever this guy was. Well, okay, there's rates, you can have an increase or decrease. This one definitely was a decrease, but an increase would go the same way. Okay, here's an example of a problem where there's all kinds of information given, and not all of it is being used. And this is very common in everyday problems. You got tons of information. What do you need? Let's just read through everything to begin with. Joseph rented a car with 8,323 miles on the odometer. Okay, so that's how far the car had been driven total. He returned it 2 days later with 8,527 miles on the odometer. He used 17 gallons of gas, and the rental cost was $153. Now, any of this information can be used, but what you need to do is find out what is the rate they want, and notice they wanted the rate in gallons per mile. Okay, well, the first guy goes up on top, so when we make our fraction here, this has got to be gallons. The second guy goes down here, and this is going to be the number of miles. Okay, well, we see that he used 17 gallons, so we can write that straight out. Okay, what were the number of miles that he had? 8,527 was what he turned the car in with the odometer reading, but when he first took it out, it was 8,323. So we can take the difference between these and see how many miles he drove. 7 minus 3 is 4. 2 minus 2 is 0. 5 minus 3 is 2. Okay, so it looked like he went 204 miles. Okay, well, again, this is a ratio, but we wanted the rate in miles per gallon. So what we have to do is divide both top and bottom here by the bottom, okay, to see how many gallons per mile were used. So if we divide both top and bottom by 204, okay, here we go. The bottom, of course, will end up being 204 over 204, which is 1 mile. That's exactly what we wanted. Remember the per business. But now, the gallons. How many times do these guys go into each other? Well, we got to reduce 17 over 204. Let's see, 10 times 17 would be 170. 2 times 17 would be 34. I think this reduces once here into 12 here. So the 17 over 204 up here, you could just get your calculator and do a decimal on this and come up with the decimal value on it. But it's also legitimate to give it as a fraction answer. So I'm just going to leave it like this and say 1/12 gallon per mile. Okay, so again, remember the rate we wanted was in gallons per mile, so we knew the first guy went on top, the second guy went on bottom, so we only got the information we needed that dealt with gallons and miles. Well, he used 17 gallons, we got that direct. We had to take the difference in the odometer readings to see how many miles. It was 204, and so what we did is we divided both top and bottom by the 204. The reason we did that again is we wanted to get this one downstairs so we could use the per notation. And upstairs, I just took 17 over 204 and just reduced it. You could again give it as a decimal value. But the idea here being then, now we can make the statement, okay, the rate was 1/12 gallon per mile. Okay, some other things that are going to lead into taking us to this rate business, to slopes and things of that sort. This says make a first quadrant graph showing an increase of $1.50 per year starting at the point 0, 0.5. And we want to label the axes. Well, first quadrant means that the x and the y are both positive. This is pretty standard in most word problems that we're just dealing with positive x's and y's. So when we make ourselves a graph, okay, here it goes. It's only the first quadrant. Now, the standard thing that goes along the bottom here is time, for instance. So since we're talking about years, that's what I'll put here. Years are going to the right. And then that means the total cost in dollars is going upwards. Okay, well, let's see. We're starting at 0, x equals 0, so 0 years and $0.5. And we're going to be increasing. Now, increasing means the graph line is going to be going upward to the right. If you had a decreasing graph, you'd start up here higher and you'd be coming downward to the right. So we know we're going to be going upward. Okay, we're going to need a few years here to put this out. So let's say there's 0 years, and this could be 1. And let's see, it's about the same distance here, 2. And this would be 3, for instance. Okay, and dollars going up, we could have $1 and $2 and $3 and $4 and $5 would just about be the top. Okay, well, this gives us a range of years to go on and dollars to do. And let's see, we are going to start at the point x equals 0. Okay, which is 0 years, and y equals $0.5. So there is the starting point right there. Okay, now here's what happens. We're increasing $1.50 each year. That's our rate. Okay, so each year we go up $1.50. Well, here's a way you can do this that we'll be working with in the future. We know this is our starting point. So let's go over 1 year. Here it is. And we have to go up then from there $1.50. So there's $0.50. And there would be $1.50. So notice this is 1 year. And this is $1.50 going this way. Well, what we've done is we've completed the change for 1 year. We've gone over 1 year and we've gone up $1.50, which takes us right to 2 here. And that happens to be another point on our graph line. And we could draw it just from that. You could do more steps, go over another year and up another $1.50, and you'd be about 3.5 here. But once you get a couple of points, just get your ruler out and graph it, and there you are. So we've labeled the axis years here and dollars going up here. And there's our starting point, and here's the rate of change. It gave us our second point. Draw the line, and away we go. Now, it's also possible to go the other way with graphs. Okay, given a graph line, we can find the rate. Well, here's the idea. Okay, first off, notice this is going downhill, okay, to the right. So that means it is a decrease. Okay. So we know that right to start with before we calculate anything. Now, the next thing you do is find a couple of spots on the graph where they cross some of the grid lines here, where it's easy to be able to pick off the values. For instance, you see right here, crosses this grid line and this one. So that could be a good point. Here's another one. There are many others here. could have done this one, could have done this one, could have done that one. They'll all give you the same answer, so all you have to do is pick a couple of them. Then, here's what we can do. We can make the same little triangle we did before. Here it is, coming down. This is my first point on the left, and we're going to the right, so heading down. So here comes the edge of the triangle right to here. I'm even with this point, so I'll now go across right to there. Read off now the changes that you happen to see here on this. Okay, for instance, we've gone down. Now you got to read the axes very carefully here, and it looks like we've gone from 3 to 2.5 to 2 to 1.5. So 3 down to 1.5. This is minus 1.5 going downward here. Now going across, okay, we've gone to 5.5, 1, 1.5, 2. So we've also gone a total of 1.5 here, 1.5. Okay, well, what's the decrease here going to be? It's going to be the change in y, which we're going to call the rise in the future, divided by the change in x, which we'll call the run in the future. So the rate here, okay, change in the y divided by the change in the x, and we'll have better ways of dealing with this when we go a little further down the line. But the change in y was negative 1.5. The change in x from here to here, we counted it off, was positive 1.5. So these guys reduce out. Plus and minus, the rate is negative 1. So whatever the x and y values are, notice of course they didn't tell us here, but for every unit change in x, we go down 1 in y, for instance. Well, this is how you can find the rate from a graph, and we'll be looking at this in more detail in the next sections.